So today we're going to be going through a Trojanized Word document, but before we do, like always, there is a link below this video to a malware analysis report that we wrote, and in that report there is a download link for a sample of this malware if you would like to follow along with this analysis. But today, this is the original Word document, this VBA2.doc. So what we're going to do is look at that in a hex editor, and we notice at the top here there's a PK header. What that means is that the file is a zip. So in document terms, newer versions of Word documents are zip files, so all you need to do to analyze the contents inside of them is to rename them to a .zip and then open it with any archive manager. And inside we see the internal structure, and if we go to the Word folder, and then down at the bottom there's a VBA project.bin. That's going to house all of the VBA code that we need to look at. So all you do is just drag that out, and there it is. So if we try to look at this in a text editor, we see that it's obviously a little unreadable. So what we can do is use a tool called Office Mouse Scanner and issue the command Office Mouse Scanner your file and then info at the very end. And what that will do is pump out a folder in the Office Mouse Scanner directory called VBA project.bin macros, and then in this case this one is called this document. Now if we try to edit that in a text editor, we can see that the code is now much more legible. So it's the original script. And if we format that to VBS script, change the language in our text editor, we can see that the code comes out a little better. But what we're going to do is actually analyze this inside of Word itself. So if we change this back to .doc and then open it in a Word editor here, you can see here that this is it's saying that there's a compatibility issue and you need to enable content. Enabling content will enable the macros to run in the background, and then the malware will continue doing what it was originally meant to do. But what we need to do is enable macros, and you do that by going to Word Options, Trust Center, and then basically disable all macros with a notification. That way when the notification pops up, you yourself can enable the macros. And what that is for it allows us to debug the VBS script. And we do that here in the Developer tab of Microsoft Word. And we go over to Visual Basic, and then we open up this document, and as we see here, it's the same script that we output before using Office Mouse Scanner. So Office Mouse Scanner is just another way to get the script out without actually dynamically running it in Word, which could potentially cause some issues with your system. But in this case, we want to run the script to see what it does, because it is fairly heavily obfuscated. So if we run down through the script, we see some interesting things like wscript shell here at the line highlighted in red. And then right below we see that it's running two variables, this GTH and FGF. And if we scroll down a little more, you can see that there's some references to ASCII, Adobe Stream objects, something here reading text into a variable. So these are very interesting things. There's a little bit of base64 here. These are interesting things that you would want to place breakpoints on if you were to debug this. So what we're going to do is go ahead and debug it, and here we see that there's quite a bit of obfuscation in these two variables, so that would be a very good variable to output. Now if we place breakpoints here and go ahead and run the file, we can see that this TGH variable and the UAB variable here are very long. And one downside to debugging in Microsoft's Visual Basic is that the variable output down here at the bottom, it's very difficult to copy the entire variable. If you try to Control A it, it doesn't work. If you try to highlight all of it, it won't actually copy everything out. And you can see here that it's cut off. We don't have the end in double quotes, so there's more content in there that we don't have. So what we can do to combat that is go ahead and type message box and then the name of the variable that you want. So in this case, we want this guy. And if we stop that and run it again, what we should get is a message box here. So we get a message box popping up with those two concatenated variables together, and we have everything. Now, as you see, you can't highlight anything in this. I actually made a video about this before of copying non-selectable window text. And all you have to do is select the window and press Control C, and then go to any text editor and then Control V it. And here we see we have the message window, title, the contents, and then the button. So all we want are the contents. And there's the contents. So if we go back, press OK. Cool. Now we want to go to our next breakpoint, which is down here. And this is going to read text into the SPE variable. And if we go one past that, we can see here that the SPE variable is now deobfuscated. That's the wonderful thing about scripts, is you don't really need to undo all their logic. You can just run through them. As long as you know where the breakpoints should be, you can get the text output in plain text and see what it's doing. So in this case, the variable is short enough that we can actually copy it out. So no need for a message box trick here. And then these are the two variables that we had, this top one and then this longer one here. So if we keep going, we come up to our variable where it's creating a WScript object. If we go one past that, we can see it's about to run this GTH and FGF. So GTH is our command/C ping variable, and then FGF is our very long variable that we got in the very beginning. So all it's doing is concatenating those together and running them. So if we go back to our text editor, if we just combine these, boom, just like that, we can see that this, as one long command, is going to issue a ping command into a null file and then launch PowerShell script. So what we can do is change our language here to PowerShell and then start separating this out a little bit. So the PowerShell portion, this is going to begin it, and pretty much wherever there's a semicolon, you can create a new line, and then we start seeing this shape out a little more to a legible script. And if we keep going down, there's a for each here, and that for each, this is basically one big loop here. And so this will be our script. So this first part here, this ping, is just pinging 100 times to the local host to 127. That's basically serving as a delay, so a delay counter, so that before this script actually goes through all the way. That's pretty common. A lot of times in malware you will see this, and you wonder why are they pinging the local host. It's usually as a delay, so instead of using like time.sleep or sleep for 5 seconds or whatever, they'll do this this ping trick. But if we want to analyze this embedded PowerShell, what we can do is copy it out, copy it to a new file, and save it as a y.ps1. So ps1 is going to be your PowerShell script. And then every version of Windows that has PowerShell in it has a PowerShell ISE, and all you need to do is open that up. And then copy in your PowerShell script that we had. Now, in order to place a breakpoint, you simply press F9 on a line where you want a breakpoint, and it'll turn red. So I have one here at the second line. So what we can do is go ahead and press run, and it pauses at the second line. So what we're interested in is the next line, this very long obfuscated line, and what we get is the NYV variable. Now, to output the NYV variable, all we do is do $, just like they have it up above, NYV, I think that's an O, and then we get the output of that obfuscated line. So we can copy out each one of these. You can see that there's 3 distinct URLs leading to PHP files with arguments of f equals 2. If we go down and continue the script, you can see that this UYP variable is going to be some sort of random number, and then UYP is having the extension .exe added to it. And then here you can see that for each one of those URLs it's going to download a file to this exe. So whenever it can get to one of these domains and download the file, it's going to place it in this random number.exe, and the random number in our case is $UYP BKPL 44935, so it's going to be 44935.exe. So if we go to these sites individually, what we get are essentially these 2 files. So what I was able to do is, with each one of these domains, the PHP and the arguments on the end, this f equals 2, what I did was just go to each one of them and change the arguments from f equals 2 to f equals 1, 2, 3, 4, 5, etc. until I stopped getting files. And each one of the files essentially came back with only two distinct files. They are these MD5 of 0F3 and 55E. And these are the other files that I downloaded over here, 3, 4, 5, and 6, and they all have, they're either this MD5 or this MD5. So just slightly different arguments in the URL leads to 2 distinct files. And so that's where we're going to end. I just want to show how to pull out obfuscated VBS. And that is, so we go from the binary VBS to the actual VBS here, which is obviously a little obfuscated. So we showed how to go into Microsoft Visual Basic Debugger here and run through it to pull out the URLs. Well, actually to pull out the PowerShell, and then how to pull up the PowerShell ISE here and separate it out to get the ending URLs, and then go ahead and download the executables that we need, and then we can analyze this malware further. As we see here, they are executables. So if you all have any questions on this video or any of our other videos, go ahead and hit us up at ringzerolabs.com. We'd be happy to answer any questions on this malware or any other malware that you have questions on.